So in the depletion and diffusion capacitance, the depletion capacitance, it is going to be exhibited by the diode under reverse bias condition. Diffusion capacitance is a capacitance which is going to be exhibited by the diode under forward bias condition. So I've already explained you how we are going to compare the diffusion and depletion capacitance with a capacitor. Compare. Sai Vikshna?
Yes, sir.
Can you explain me how we can compare the forward bias with a capacitor and reverse bias with a capacitor?
Yes, sir. Like we have PN junction and we have a depletion layer in between. The same way we have a dielectric medium between the plates.
Okay. Then
Sign only that.
okay, fine, good. Yes, Nandan Reddy. Sorry. So capacitor, the depletion capacitor and diffusion capacitance is being compared with the diode's behavior. So whenever a diode, just simple definition, whenever a diode is under forward bias condition, it exhibits diffusion capacitance. Whenever a diode is in reverse bias condition, it exhibits depletion capacitance. Okay, this is only the definition. But if they are asking you to explain, then you have to tell that. So whenever PN junction of a diode is compared with two plates of a capacitor, the positive plates and negative plates, and the forward bias condition is compared with the plates which are moving closer together, where the accumulation of the charges over the plates increases. In the same way, in the PN junction, the movement of the charges through the junction will increase. Okay, this is the explanation for diffusion capacitance. Depletion capacitance, it is compared with the positive and negative plates of a reverse biased PN junction, where the P and N layer are moving away from each other because of the creation of the depletion region. This is compared with the positive and negative plates of a capacitors which are moving away from each other. So this during this case, the accumulation of the charges over the capacitor decreases. In the same way, in diode also, the movement of the charges across the junction will be reduced. So this behavior of the diode is assumed to be the behavior of assumed to be the depletion capacitance. Okay, these are the two things you should know. So after knowing this, now we come back to AC equivalent circuit. So AC equivalent circuit. So this AC equivalent circuit, as I told, we are going to write the battery with a resistor. This is our usual thing, whatever we have. To this, we are going to connect one capacitor. Okay, we are going to connect one capacitor. This is known as the equivalent circuit for the diode. This is known as the equivalent circuit for the diode under forward bias condition. But under reverse bias condition, this is for forward bias condition for AC supply. Under the reverse bias condition, we'll write only one resistor and one capacitor, because in reverse bias condition what happens, the current will be flowing in this direction such that the diode will become reversed. Okay, I'll write it and show. So diode is compared to a switch or open circuit, like so. After that, you'll have one battery, one resistor. Okay. Now suppose under reverse bias condition means current will flow in this direction. The switch is opened, or we can tell open circuited. What is the total resistance offered by the open circuited switch?
Zero, sir.
Huh? Resistance offered by open switch. Huh? What is the resistance? Zero or infinity? Zero. If it is zero, then current has to pass through it, no?
Sir, when there's no opposition, the current can pass, sir.
No, I'm telling now switch is open. Switch is open will be switch is open means opposition only, right? Means current cannot pass.
Yes, sir.
So open switch means the circuit has broken. So the current cannot pass. Current cannot pass means we consider that as resistance only. So now tell me, what is the value of the resistance?
So infinity.
Infinity.
Yes, because see, always remember one thing, whenever under open circuit, in ideal case, the open switch is always considered to be the maximum resistance, because open switch is not allowing the current to pass through, no? So something which is not allowing the current to pass through is always treated as resistance. In that way, we are going to consider this open switch as maximum resistance. In the same way for the closed switch, what is the resistance?
Minimum.
Zero.
Minimum or zero, right? So this is what we are going to consider. So when you are having maximum resistance which is offered by open switch, so together what we'll write is, we'll write RR. Okay, we'll write it as RR. So it will be the maximum reverse resistance. It will be maximum. So that's why we will not even write this battery or this switch or anything, because this itself is maximum. Then there is no question of no reason to write all those components. But here in the forward bias condition, we are going to write a battery along with the resistance. Battery along with the resistance we are going to consider. Okay, so now this is the AC equivalent circuit for the diode under forward bias condition. This is the AC equivalent circuit of the diode under reverse bias condition. Why we have written only one resistance here? Why we have not written battery? Yes, tell me. Just now I told. Why I have written single resistance?
Has maximum resistance.
It has the maximum resistance. If you are having maximum resistance, then all the other things becomes ignorant here. Here, since the resistance is minimum, it is dynamic resistance RD, it is minimum, we consider a battery. This is the AC equivalent circuit. Suppose if they are asking you DC equivalent circuit, what you will write? If they are asking you DC equivalent circuit, what you will write? This is for AC, this is for, I am asking for DC. In last class itself we have done, no? DC equivalent circuit is nothing but diode approximation. At least now can anyone tell me?
The resistor and an idle diode.
And a battery.
Yes.
Diode approximation we are done, no? Piecewise linear. Piecewise linear characteristics. That these are all DC equivalent circuits only. Okay? I'm repeating again. AC equivalent circuit means it contains a capacitor, and these are the two formats of equivalent circuit we are having. DC equivalent circuit means you need to write the piecewise linear characteristics with the resistor, with a diode, ideal diode, and a battery. This is the DC equivalent circuit. Remember it. Diode, they can ask you diode approximation, or they can ask you explain DC equivalent circuits. Then also you should write diode approximations only. And suppose if they're asking AC, explain diode AC equivalent circuits, then you have to write junction capacitances. There are two types of junction capacitance: depletion, diffusion. After that, you have to write these circuits. If they're asking you to just write the circuit for 2 marks, then fine, just write the circuit. If they're asking for explanation, then you have to explain. I am repeating again, for DC equivalent circuit, you should write the 3 approximations with their figures. For AC equivalent circuit explanation, you have to write the capacitors. What are the different types of capacitors you'll have? Diffusion or depletion capacitance we have, and in which biasing we get. After that, you should write the circuit. This is what you need to do. After this, one more important topic we have is reverse recovery time. It's reverse recovery time. So what is this reverse recovery time? Let us understand it by using the graph. By using the waveforms, we'll try to understand. So this is considered to be the forward voltage. This is considered to be the reverse voltage.
Sir, excuse me, sir.
Yes.
I'm referring the textbook which you are told to buy, no, sir. With that, I'm referring the book and I'm listening to the class so I can understand, right?
Yeah.
So I can follow both. I can follow, right? I mean,
I'm doing whatever. I'll be using my textbook only to teach you.
okay, sir. That textbook is enough, no, sir.
It is more than enough.
Okay, sir. Thank you.
So this is the forward bias. This is the reverse bias. See, what happens is we have a p-n junction, p type and n type. Now, first let us take step 1. In step 1, what I do is I'm going to connect this diode in forward bias condition. So when I connect it into forward bias condition and I have fixed some good voltage of 5 volt. So now can the diode become forward bias? Can the diode become forward biased?
Yes, sir.
Yes, sir.
It can become, right? Because it is greater than the required threshold. So now the current will be flowing. So since it is DC supply we are giving, for a fixed DC voltage, can I call for a fixed DC voltage? I'll be getting fixed DC current, right? For DC voltage, does the current change? Current will fluctuate? All right. So this is the current voltage I'm supplying. For this voltage, I'm plotting the current versus again time. This is also time. So I'm getting constant current. Okay. So current is flowing through this. And suddenly at this particular time, what I'll do is I'm going to suddenly give this voltage. This voltage is what? What is this voltage?
Reverse.
Reverse voltage. I'm giving negative voltage means it becomes the reverse voltage. When I give reverse voltage, what will happen to the p-n junction? This is our step 2. It was running in forward bias. Suddenly I'm reverse biasing it. Instead of plus 5, I'm giving minus 5. What will happen? Or what should happen according to you? Just the basic question I'm asking. Whatever you know, you should open your mouth. We should have an interactive session. Then only the class become interesting. Otherwise, you'll feel bored and sleepy. Even I'll feel sleepy if you're like this. Tell me, what will happen to the p-n junction? I'm asking with respect to current. If I reverse, so you'll be having more current, or what will?
No,
what?
No flow of current.
No flow of current, right? But practically what happens is when you change the voltage, the current direction will change. Okay, it was in the positive direction. It will reach negative in the opposite direction. It will reach. Instead of becoming 0 or minimum, it will be at same level. See, whatever the current you are having, the same amount of current will be there, but it in the opposite direction. After that, slowly it will decrease and it will reach the reverse saturation level. Actually, the required current should be this one. This is the current it should have, but it takes some time to reach that level. So this much time duration, we are having some amount of current. Actually, we should have only this much current. It should end up here only. Your curve should come here only, but it is not doing like that. It is going to this opposite peak, and after that it is decreasing. Are you getting what I'm telling? So the time taken by the diode to reach to its reverse saturation level, time taken by the diode to reach to its reverse saturation level is known as reverse recovery time. See, this it is taking this much amount of time to reach this level. Actually, theoretically speaking, it should be zero or small amount of reverse saturation current will be flowing because of the electrons which are stuck in the junction under forward bias condition. But it will not happen like that. Practically, it will be having initially when you suddenly reverse bias, it will have same amount of current. Whatever you have here, the same amount of current will be flowing in the opposite direction, and slowly it will decrease to this minimum level. Now the question is why this will happen. So when I reverse bias, actually the current should be minimum, but why we have this? Why it happens like this is when you are forward biased, the PN junction, the charges are freely moving. They are freely moving. When you suddenly reverse bias, what happens? There are many huge amount of charges which are in the transition. They are moving. It is just like in a junction, the vehicles are moving easily. Okay, and suddenly there is a signal. Suddenly a red signal will come. Initially there was a green signal. Suddenly red signal will come. What will happen? They have to move. They have to move because there is there is huge number of crowd. They cannot stay in the junction or they cannot go back. They have to move forward. In the same way here, during forward bias condition, the electrons or the charge carriers, which they will be freely moving across this junction. But when you suddenly reverse bias, they cannot suddenly go back. They have to move forward only. So that's why those charges which are held up in the junction, because of those charges which are held up in the junction, we are going to have this reverse this amount of current. So when one by one electron starts decreasing, that means when the traffic is going to clear, it becomes free. The junction becomes free. No, in the same way, when the number of charges shifts or they are clearing from the junction, this area, what happens? Slowly the current starts decreasing. Because what is the definition for current? Basic definition for the current?
It's a flow of charge.
Flow of charges is known as current, right? So because of these charges which are held up in the junction, because of their movement, we had this much amount of current. And slowly when number of those charge carriers are decreasing, so the current is also decreasing. So slowly they are decreasing and they are reaching the reverse saturation level. Okay, the time taken by the diode to reach to its reverse saturation level is known as reverse recovery time. Now, in this, we are going to have one more graph. If you have the book, you can see there is one more graph. So in that graph, we are why this happens? The question is why this happens. So to analyze this, we plot again the current So this is the forward current, this is the forward voltage, and this is the time. This is forward bias, this is the reverse bias. This is the reverse recovery time. Current, reverse saturation current. So you can see this is the voltage and this is the voltage which you are given in the forward bias condition. You are to make it negative. How you will make? Suddenly will you make negative? Or there was 5. Suddenly you will make -5? Or what you will do? In a power supply, you will be having a knob, right? That knob you are going to rotate, right? When you are going to rotate this knob, then only you can increase or decrease the voltage. So now you are at +5, you are rotating the knob towards -5. You need some time, right?
Yes, sir.
That time is this one. So this is the forward voltage time. So when you are changing it, even the diode takes some time to adapt to the new voltage. It cannot suddenly adapt. It takes some time to adapt to the new voltage. So that time is known as the fall time. That time is known as the fall time. So because of this fall time, this much of fall time, we are going to have this reverse recovery time. So actually the fall time, now just let me see. So whether the fall time should be more or less. Fall time should be more or less. I'll tell fall time is the time taken by the diode to adapt from forward bias to reverse bias voltage. Okay, now tell me whether the fall time should be more or less for a good diode.
Less, sir.
Yes, sir.
Less, sir.
Less, sir.
Why it should be less? Is your answer is correct? Hmm? Hmm? If the fall time is less, then your diode can adapt to the new changes very fastly. If your fall time is very large, then the diode cannot adapt for the new changes. It takes some time. Okay, that's why in general what we tell is the minimum, the time which is required by the diode to come back to its reverse saturation level should be 10 times greater than reverse recovery time. So it is taking this much amount of time. So actually TRR should be 0.1 times TR minimum. That means only this much amount of time it should take to come back to reverse to the reverse saturation level. So your TRR should be equal to 0.1 times TR minimum, recovery time minimum. So that much amount of less time it should take to come back to its reverse saturation level. This level it has to come, but it is taking this much amount of time. So it has to suddenly adapt to the new changes, means it should work at this particular level. This TR min is the minimum reverse time required. So in that also you should take 0.1 times of that minimum reverse recovery time. So that will give you the TRR. So just remember these points. Reverse recovery time means it is the time taken by the diode to reach to its reverse saturation level. After that, write these two graphs. This is forward voltage, reverse voltage, forward bias, reverse bias. Initially, the forward bias PN junction will be forward bias. Later on, suddenly when we suddenly reverse bias the diode, during that time, the diode takes some amount of time to reach to its reverse saturation level. Until that, large amount of charges are still present across the junction. Because of that electrons which are present across the junction, you will be having some amount of current. Initially, it will be almost same amount of current what it was having in the forward bias condition, but it will be in reverse direction. But slowly the current is going to decrease and it is going to reach the reverse saturation level. So the total time taken is TRR, but actually the TRR should be equal to 0.1 times TR minimum. So this means that the reverse recovery time should be very less. So reverse recovery time is the time required for the current to decrease to its reverse saturation level. Okay, so these are all the basics. Till now, whatever we studied, all these things are the basics about the PN junction. Now, actually, your semiconductor devices chapter begins. These are all the basic things they will be asking. So now the question is, what are the questions that can be asked till now? Okay. First question. Explain PN junction with VI characteristics, or explain working of PN junction with its VI characteristics. So you have to explain unbiased condition what happens, forward bias condition what happens, reverse bias condition what happens with its VI characteristics. That is one question they can ask. Next, after this, they can ask you diode parameters. Diode parameters. So define the following or explain the different diode parameters. You should define them. After that, they can ask diode approximation. So after that, they can ask problem on the DC load line. or temperature dependence of VI characteristics. After this, the junction capacitance, then reverse recovery time. These are all the possible questions you might get. So that's why, so start, be perfect with these things. Next is diode application. Before that, we have to do one problem based upon a derating of a diode. We had not covered it. So the question, it's in the page number 20. Calculate the maximum current that can flow through (759). So as shown in figure, at device temperature 60 degree and 80 degree, PD is equal to 250 milliwatt. So this is the question they are given. Now what I'll do is I'll take this as 80 degree, this as 90 degree, otherwise you will tell the same answer. So I'll take the circuit. I want everyone to do it. You need to keep a separate rough book, workbook for basic electronics, because later on you have problematic chapters there you need to work out. So I can ask you to scan and upload that anytime in the GCR. And in Google Classroom, I have shared you the link also, and I have shared you invitation also. You guys are so busy that you are unable to accept that invitation. I know you are very busy, you cannot search the code. That's why I only sent the invitation. But still you are so busy, you cannot check your email. At least do it today. So this is 7 volt. Okay, so here they're asking maximum current through this, maximum current through the diode. So current through the diode is been asked, and what and all they have given? They have given power dissipation. That means power is been given. So it is 250 milliwatt. The power is given. So now 250 milliwatt power is being given. So now they are asking for Iz max. But here in this case, we are not very clear that whether they are asking for the under which temperature. That means they're asking for 60 degree or 80 degree. I mean 80 degree or 90 degree. That's why what we do is we will do for both. They're not telling at what temperature they're expecting, whether they're asking the maximum current at 80 degree or maximum current at 90 degree. We don't know. That's why we will do it for both the cases. How to do for both the cases? So we can take P1 as 250 milliwatt. P1 is 250 milliwatt, and the diode voltage is, it can be taken as VF or VZ, anything, 6 volt and input volt 7 volt and input voltage is 30 volt. So do we have any formula which relates power, voltage, current? Do we have any formula which relates all this?
Yes, sir.
Power dissipation.
So P is equal
Basic formula P is equal to
into I.
V into I, right? I want I, so rearrange it. I is equal to P by V. P is 250 milliwatt and V, which V we need to take? Whether I need to take 30 volt or 7 volt? 7 volt, because I am finding out the current, maximum current through the diode. That's why I need to take 7 volt. Yes, tell me what is the answer? Use your calculator. What is the answer?
142,857.
37 point.
No, sir.
35.7.
35.7.
35.4178.
Yes, sir.
Just 2 decimal point is sufficient.
Sir, actually 7 in the first.
Okay, 35.7.
Yes, sir.
Okay, fine. So this is in terms of milliampere we have got. This is for P1. P1, that is P1 is nothing but at temperature T1. Now we need to find out the maximum current at temperature T2, because they have not specified for which they are asking, which temperature they are asking. That's why we have to do for both. So we know the temperature T2, but we don't know what is P2. So find P2 first. For P2, we have the formula P1 at T1 minus T2 minus T1 into derating factor. Okay, derating factor. So they are not given the derating factor. So what is the standard value I had told to remember? If they are not given, I had told you need to remember
2.2, sir.
yes, 2.2 milliwatt per degree C. So now multiply this 250 milliwatt minus 100. Oh, sorry, 220. Not 220, 22. 22 milliwatt. How much you'll get?
So 228.
228 milliwatt. This is our P2. Now use the same formula. Imax is equal to P2 by Vz. So 228 milliwatt by 7.
$32.57.
32.57 milliamps. So this is the value. Okay. So this is about the today's class.